Today we're going to start talking about the first topic in your Chemistry IB book, which is stoichiometry. First of all, we have to know that we have three states of matter that we all should be familiar with and their characteristics, including 1 solid, 2 liquid, and 3 gas. These states of matter differ in arrangement and movement. The distance between particles, for one, is closest in solids and farther apart in liquids, and the farthest in gases. The arrangement in solids, as you see in this picture, is regular, and the arrangement in liquids is random in gases. The shape of solids is always fixed, so wherever you put a solid, it will maintain its shape. And in liquids, there are no fixed shape, they take up the shape of the container. And in gases, they also have no fixed shape, so if you place a gas in a container, it will fill that container. The volume of solids is fixed, and the volume of liquids is also fixed, but it's not fixed in gases because, as we said, it will fill the container. So its volume is depending on the size of its container. Movement. The solid particles vibrate in their movement pattern, and in liquids, the particles move around each other, and in gases, they move around in all directions. The speed of movements is slowest in solids, a little bit faster in liquids, and the fastest in gases. Energy is also the lowest in solids and higher in liquids, and the highest in gases. Forces of attraction between particles is at its highest or strongest in solids and lower or weaker in liquids and the weakest in gases. To change the state of matter, we have some terminology that we should be familiar with. For example, if we are changing a matter from solid to liquid, it is called melting. And if we change that liquid to gas, it is called boiling or evaporation. And if we change directly from solid to gas, we call it sublimation, as in iodine and carbon dioxide, where they sublime at atmospheric pressure. And we can change gas to liquid by a process called condensation, and this liquid can be changed to solid by a process called freezing. And the gas can be changed into solid directly by a process called deposition or desublimation or reverse sublimation. Heating curve. If we bring a substance in its solid form and we put it under increasing temperature and we plot the temperature change in that substance with time, we will get this drawn graph. First of all, to understand, let's imagine this. We have a solid substance that we started heating from a degree of 20 degrees as in the graph. Its temperature will start rising till it reaches a point where the solid particles start turning into liquid particles, and this is called melting. What's new here is that the temperature of these particles will stay constant in this example at 50 degrees until all particles turn into liquid. When all particles become liquid, the temperature will start rising again till it reaches something called the boiling point, where these liquid particles will start evaporating to form a gas. And the same thing, these liquid particles will have the same temperature until they all have been transformed into gas particles. When all these gas particles are formed, the temperature will rise again. This is a explanation to what we have just said. When we start heating solids, the particles will vibrate more violently, and when these particles vibrate, they will gain kinetic energy. And this kinetic energy will be used to overcome the attractive forces between the particles. Now, when the particles start turning from solid into liquid, or when they reach the melting point, we will have solid and liquid particles mixed together, and the temperature will stay constant until all solids are liquids. When we have all solids, melted to liquid, the temperature will start rising again. We will have more heat and the kinetic energy of these liquid particles will increase again. So these particles will move around each other more quickly, and again this heat energy will be used to overcome the forces of attraction. And this kinetic energy will increase until we reach the boiling point. When we reach the boiling point, temperatures will stop rising until all liquid particles are turned into gas. Now, the second subject is called chemical changes. There are some terminology that we have to be familiar with, including atom, element, compound, and molecule. So, in matter or anything on this earth consists of elements or compounds or atoms. So, the smallest thing of matter is called atom. So, I want you to imagine it as in this picture. As for example, these particles in the solid make up something matter, and the smallest circles are the atoms. So the smallest part of a matter is called atoms. Now, we have something called an element, which is a pure substance that contains only one type of atom. So, if we were to bring two atoms of one substance, for example, oxygen, or three, or four, or so on, till we reach millions of atoms, but only of one type, this is called an element. Now, if we bring two or more elements together and mix them up chemically, this is called a compound. So, if we bring carbon and oxygen and mix them together chemically, they will form something called carbon dioxide. And this carbon dioxide is called a compound. For example, we have two elements here, a sodium on the lower left and chloride in the middle. As you see, the sodium is gray and has low melting point, and chloride is yellow and poisonous. If we mix them up together, they will form something called sodium chloride. Now, the resultant is very different from both reactants used to make up this sodium chloride, and the product will have different chemical and physical properties. This is very important. The product that we made will have different chemical and physical properties from the elements that it is made up from. Now, we have something called the chemical equation, where elements, when they combine to form compounds that we just talked about, they will combine in only fixed ratios. So, for example, we have 1 gram of hydrogen that combines with 8 grams of oxygen to form water, which is H2O. So, hydrogen and oxygen will combine to form water in a fixed ratio of 1 gram of hydrogen to 8 grams of oxygen. So if we have 2 grams of hydrogen, we will need 16 grams of oxygen. And if we have 3 grams of hydrogen, we will need 24 grams of oxygen. Another example is carbon and oxygen. They can combine to form carbon monoxide. And we will always use 1 molecule of oxygen gas with 2 atoms of carbon to form 2 molecules of carbon monoxide. So they combine in a fixed ratio of 1 molecule of oxygen. Notice we said molecule of oxygen and not atom of oxygen because it's 2 atoms of oxygen combined together to make a molecule of oxygen. So the fixed ratio is 1 molecule of oxygen and 2 atoms of carbon. So if we have 4 atoms of carbon, how much molecules of oxygen do we need? We need 2. Now, the next subject is something called the balancing equation. We have 2 parts of an equation, something called the reactants and products. So if we look at this equation in the bottom, we have 2 carbons plus O2 gives us 2 carbon monoxide or 2CO. So the substances on the left, which are the 2C and the O2, are called the reactants because they react to give us 2 carbon monoxide. And the 2CO is called the product, okay? The amount of products should equal no more or less to the amount of reactants. So when we add up the amount of products should equal the amount of reactants. So for example, if a reaction involves 5 grams of one substance to react with 10 grams of another substance, what is the amount of the products? The amount of the product would be the sum of the reactants. So we have 5 grams of one substance and 10 grams of another substance, so the amount of products would add up to 5 plus 10, which is 15 grams. Now, the equation on both sides should have the same type and number of atoms. So if we have 3 atoms on the left, we should have 3 atoms on the right. And if we have 2 molecules of oxygen on the left, we should have 2 molecules of oxygen on the right. We have a number next to atoms. For example, we have a 2 next to the C in this example. This number is called the coefficient. Now, the coefficient should only be whole numbers, so it cannot be a half or 2/3 or 1/4. It can only be whole numbers, as in 1, 2, 3, and so on. We have to balance equations by making both sides add up to the same number and type by only changing the coefficient. So if we have O2 on the left and O on the right, we cannot make O on the right to O2, but we can change the coefficient next to O, which is 1, to 2. So let's take an example. In this example, we have C3H8, which is a gas called propane, added with 5 molecules of oxygen to give 3 molecules of carbon dioxide plus 4 molecules of water. So in the reactants, we have 3, if we see, we have 3 atoms of carbon, we have 8 atoms of hydrogen, and we have 5 times 2, which is 10 atoms of oxygen. Now we go on to the product side. We have 3 atoms of carbon, we have 6 in the first compound, 6 atoms of oxygen, and 4 other in the second, H2O, which adds up to 10 atoms of oxygen, and we have 8 atoms of hydrogen. So if we compare them together after writing them down in the order you see, you can see that it is balanced. Now, the compounds or atoms or molecules used up in an equation have states that we talked about in the beginning. These substances can be solid, which is represented as S, or gas, which is represented as G, or liquid, which is represented as L, or aqueous. Aqueous means that this substance is dissolved in water. Now, we have to learn to balance equations, which is a very common and popular question in your first paper. So, for this example, we have to balance the following equation and find the sum of coefficients. So if we see, we have N2 plus H2 and NH3. On the left side, we have 2 atoms of N. On the right side, we have 1 atom of N. So let's add the number 2 on the right side. Now, if we add the number 2 on the right side as a coefficient to 2 and H3, we will have 2 atoms of N on the left and 2 atoms of N on the right. And now let's go to the hydrogen. After adding 2 to the right side, we will have 2 atoms of H on the right side and 6 atoms of H on the 2 atoms of H on the left side and 6 atoms of H on the right side. Now, how can we make them equal? By adding 3 as a coefficient to H2 on the left. So now we'll have 6 atoms of H on the left and 6 atoms of H on the right, and this will be balanced.